Hey guys, today's topic is going to be about eclipses. We are still talking about the moon and its relationship to Earth. And basically, if there were no moon, there would be no eclipses. So let's get on with it. All right, there are two types of eclipses. One is called a solar eclipse. Now, solar means sun. So, a sun eclipse, that means the sun gets covered. The second type is lunar eclipse. Luna means moon. And in this case, it means the moon gets covered. So the word solar indicates what is getting covered in the eclipse. Lunar shows that the moon is getting covered. Okay, so we'll first talk about the more famous eclipse, which is the solar eclipse. Now, the way that this works is that the moon is up in the sky and so is the sun. The sun is way bigger than the moon. It's about 4 million times bigger. But the sun is also much farther away than the moon. So in the sky, they seem like they're the same size. So at some point, if the moon crosses the path of the sun, it's going to cover it. All right, so about twice a year, as the moon is revolving around Earth, it sometimes gets in the way between Earth and the sun. And because they are both the same size in the sky to us, the moon can actually cover the sun completely, causing what we call a complete solar eclipse. So in this case, the moon covers the sunlight and the shadow of the moon is on Earth. So in this picture, you can clearly see that the moon is between the sun and Earth and that the moon's shadow is on Earth. But as you can see at the bottom of the picture, the shadow has two parts that have names. There's the darker part of the shadow, and there's a lighter part of the shadow. The darker called the umbra, and the lighter called the penumbra. Now, what's that about? We'll get back to this picture in a minute. Now, if you've looked at any shadow before, you might have noticed before, and if you haven't, then do it at home now and try it out, that any shadow has a very dark central part, and it has a lighter outer part. That dark central part is what we call the umbra, and the lighter part is called the penumbra. When a solar eclipse happens, the moon casts a shadow with the umbra and penumbra on Earth. In this picture, you can see the moon's shadow on Earth, and you can see that it has two parts. At the bottom, it's even labeled. It says umbra, the darker part, and penumbra, the lighter part, right? Now, if you happen to be standing at the umbra part on Earth, then you'll see a full eclipse. If you're standing in the penumbral part, you'll see a partial eclipse. Now, what does that mean? Well, it means that if the country you're standing on is in the umbra part, then you will see that the moon fully and completely covers the sun. But if you're not standing in the umbra, if you're in the penumbral part on Earth of the shadow, then you will see that the moon covers the top part of the sun or the bottom part of the sun, but it never fully covers the sun. Let me show you a video.
A solar eclipse happens when a new moon moves between the Earth and the sun, blocking some or all of the sun's rays from reaching the Earth. By cosmic chance, even though the sun is 400 times wider than the moon, it's also 400 times farther away. Therefore, the two objects appear the same size in our sky. Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits. Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth: a smaller, darker shadow known as the umbra, and a larger shadow known as the penumbra. There are four types of solar eclipses. The first and most spectacular is a total eclipse, when the moon completely covers the sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the moon passes in front of the sun off-center, never fully covering its surface.
To quickly summarize the solar eclipse, you can see from left to right, the moon covers the sun, then more, then more. Then in the center, you can see that it has completely covered it. And behind it is a big white halo around the moon, which is what we call the corona. The corona means crown in Latin. And then as it moves right, you can start to see the diamond ring, which means the sun is re-emerging from behind the moon. And then the moon keeps moving until the sun reappears. And now for the second type, the lunar eclipse. In this case, lunar eclipse, meaning the moon is the one that gets covered by a shadow. Whose shadow this time? It's Earth, because guys, the sun is always the source of light. So it's either the moon's shadow on Earth, solar eclipse, or Earth's shadow on the moon. So it's lunar eclipse. In this case, the Earth is the one that's between the sun and the moon. Now, in the case of the lunar eclipse, as you can see, the Earth is the one that's between the sun and the moon. The moon goes behind Earth's shadow. Now, once again, the shadow is divided into two parts, the umbra and the penumbra. So the moon is moving through Earth's shadow, first in the penumbral part, then the umbra, then into the penumbra again, and then out. Usually the type of moon is a full moon at this stage. This is more clear in this image. As you can see, going from bottom to up, it goes through the penumbra, then the umbra, then the penumbra again. Again, it should have been a full moon, but then it gets completely covered into the shadow. I'll show you what it looks like. So you can see here from left to right, it used to be a full moon. Then in the second picture, there's a bit of a shadow on the moon, and the shadow gets bigger and bigger until it's completely inside the shadow. When it's inside the shadow, it turns a shade red, and I'll explain that in the next video. Then as it emerges out of the shadow, it gets lighter and lighter until it becomes a full moon again. Some of you may have seen this 2 years ago, or last year perhaps, in the North Coast.
A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts two types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow, known as the umbra. There are three types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the three types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much dust and clouds are in the Earth's atmosphere. Following volcanic activity, ash can block out enough light to render the moon a darker red or even near black. A partial lunar eclipse, the second type, occurs when the Earth, moon, and sun don't perfectly align, so only part of the moon passes into Earth's umbra. Earth's shadow appears very dark on the side of the moon facing Earth. Last, a penumbral lunar eclipse occurs when the moon passes through Earth's penumbral shadow. The event is so subtle that most people don't even notice. The moon will appear just slightly darker than normal. Lunar eclipses occur up to 3 times a year and can be observed from the entire nighttime half of the Earth. Unlike during a solar eclipse, it's safe to look at the moon with the naked eye during a lunar eclipse.
So there you have it. I hope you understand the difference between solar and lunar eclipses and that you understand what they mean in the first place. As you can see, this is a quick table to demonstrate the differences between each. Please study it carefully, and then I think you should be okay.